Hi, I'm Helen Rosenfeld. I'm the Executive Director of the Massachusetts Science and Engineering Fair. Thank you so much for having us as participants in your Global Summit. The Science Fair is a Massachusetts statewide program whereby we have over 1,500 students a year that compete across the state with their science and engineering projects. We also support teachers with professional development. We support inquiry-based learning for students and support students in their hands-on research throughout the year. During this past summer of COVID cancellations, we saw this as an opportunity to engage more with our alumni and had a series of projects of different kinds that we positioned as projects students could get involved with. And so we went from having a science fair that was held annually at MIT in the gym to an online, pivoted quickly and had an online conference whereby students submitted 5-minute videos and our judges assessed them. Not nearly the same excitement as an in-person conference, but given the circumstances, it allowed us to continue with the fair. With that in mind, we thought, what could we do that could create a virtual experience? And that was sort of the kernel of this project, was what kind of online experience could we create for students that would allow us to have a virtual science fair. So the students that are with us today, we're excited about that concept, and we all came at it with different ideas. And we're here today to talk about the experience of thinking through the project, developing the project, and what we've learned from it. So with that, I'd like to invite everyone to introduce yourself, your name, your school, your grade, the science fair project that you most recently did, and perhaps an interest area that brought you to this project.
Hello, everyone. My name is Akash Sankari. I am a senior at North Attleboro High School in North Attleboro, Massachusetts. My most recent science fair project dealt with designing portable nuclear reactors and how we can better implement portable nuclear reactors, shrink them down even more, generate a lot of energy out of them. The specific interest that brought me into this VR internship is that throughout my engineering projects, I've always used computer-aided design, and I've used computers to create models of my projects. And obviously that translates pretty well into VR since you're using computer tools to generate models in a VR environment. So that's why I was interested in this project and decided to join the team.
Hi guys, my name is Maimu. I'm a second-year student at McMaster University in Hamilton, Ontario, studying material science and engineering. I was specifically interested in this project because as an engineer, I want to learn about leadership and how to take a product from the design state to the end goal. My most recent science fair was a project designed to neutralize carbon using algae-based reservoirs. Essentially, carbon would go into the reservoir and oxygen would come out.
Hi, my name is Arna Mishra. I am a junior at the Massachusetts Academy of Math and Science. And so my recent science fair project was developing a cane that the visually impaired can use. And it used sensors to tell them where an object was in a given space and how far away they were from it. So something that brought me here today is simply my interest for mechanical engineering and, as Akash talked about before, computer-aided design. And I really feel like that's something I'm really interested in.
Hi, my name is Helen Liu. I'm a junior at Shrewsbury High School. My recent science fair project was using machine learning to mimic, for a drone to mimic drone patterns, bee patterns. And also I joined this internship because I thought it was a good chance to learn from others.
Hi everyone, my name is Nilasha and I'm a senior at Shrewsbury High School. My most recent science fair project was basically creating a machine learning backbone for an application that would give patients with glaucoma customized reminders to take their medication. I was interested in this internship just because in general, I'm interested in computer science and different aspects of it. And since it's just such a vast area of knowledge, I just wanted to uncover more of that through this project.
Hello, everyone. My name is Shashank Jamale. I'm currently a senior at Billerica Memorial High School in Billerica, Massachusetts. My most recent science fair project centered around the idea of using machine learning and a few other computing methods for detecting atrial fibrillation and similar heart arrhythmias in high-risk patients, especially using wearable sensors such as Fitbit and Apple Watch, devices that are very accessible. And I'd say, obviously for a project like this, there are a lot of technical skills that are involved. For me, what were most valuable were the design and 3D modeling.
Hi everyone, I'm Shravya Anisetti, and I'm a junior from the Massachusetts Academy of Math and Science in Worcester, Massachusetts. My most recent project for the science fair was titled The Effect of Novel Natural Antioxidants to Treat Alzheimer's Disease, and I used a C. elegans model to model the disease. And some of my interests coming in were in STEM in general, and I was also very interested in web development and engineering.
Great, thanks everyone. Clearly everybody comes at this from a different angle, and I'd love for you to talk a little bit about how this project unfolded. As we talked about, we sort of visually knew that we wanted to recreate an experience that connected us to our sort of in-person MIT fair, and we used that as the backdrop. But we really had to think through what was this going to be as a project. Does anybody want to share some of their experience in that thought process and how it unfolded?
I'll go first. So one of the interesting things we talked about at the beginning of this project was that we originally went at it as a traditional science fair. We'll have a VR space with like our boards and everything in a line, just how we would have it at MIT. But later talking about the project, I think my moon brought this up, is that just because, the regular science fair is like that does not mean that a VR science fair has to be like that. VR, as my moon said, gave us the opportunity to do like bigger and better things, which would not be possible in like a regular science fair. So I took that really to heart. I think that was a really interesting point that he brought up. So really our idea was like kind of blending both the traditional science fair, with the boards and the tables, but also kind of bringing in that like larger than life aspect of VR, but kind of like basically blowing up our presentations in like a bigger screen, so that like, you could go ahead, and we'll show this later, but you can like go to a board, click on it, and you can kind of like blow up the board and see a presentation of everyone's project.
Thanks. Anybody else want to contribute? How the
Okay.
thought process changed over time, or how you engaged at different points?
Well, I'll tag team a little bit here. I think what Akash was saying was a very important aspect of what we were trying to do, because we're no longer limited within the physical reality in which we exist. When we have this virtual space, we can do a lot of different things. I know one of the students here suggested we make massive models of what could be within the science fair, like representations. And that's something that we plan to integrate into further models. Um, because we have this ability for scalability, because this is a virtual science fair, we can expand this infinitely. This really was an interesting sort of technical challenge, as well as like a design challenge, as to how to make a science fair for both virtual and more interactive than a real life science fair.
So you've all come from a variety of schools across the state, and some of you didn't know each other beforehand. So how did you find the collaborative process, and how did you sort of unearth each other's skills and where you best could contribute to the project?
I can talk a little bit about that. So, I think one of the main challenges we were facing heading into this project was basically striking our optimized combination of how to present information best. And, obviously in these last several months of 2020, with cancellations, club trips, science fairs canceled, things like that, it's difficult. Like, how do we make up for that unique human to human interaction between a person who's worked on a research project and the person they're presenting it to. But like Akash and Mamoon have hinted at, we do lose that when we go to a VR setup, but we also gain other things. So I think what was really important is figuring out how we can use our technical skills to kind of create the optimal environment for students to showcase their project. And a lot of that was making it simple to be able to add your project in through slides or video.
Had anyone done any other projects in VR before, or had any exposure to this, or was this a first time effort?
For me personally, this was actually the first time that I dived deeper into VR and AR. And so it was obviously a great experience, just learning along the way. And everyone was really great at teaching what was needed to create this. So I think it was a great experience overall.
Does anybody else want to share any of the aspects around the collaboration, things that perhaps worked really well, other pieces that were perhaps a little more challenging?
I can go. I will say that personally, I had like absolutely zero experience with AR and VR. So I think just kind of figuring out where I could put my talent into this project was initially kind of confusing, but eventually, like, you know, I figured it out, and this community was just so like welcoming. Everyone here is very, very nice to work with. And I will say, like, one challenge was kind of like was mentioned before, like, since we don't have that in-person interaction, I'd say that the slides have to be like definitely modified a lot, like when we're presenting our projects. So just figuring out how we can bring that personal touch like within just text and visuals was a bit of a challenge, but it was definitely a very rewarding experience.
Great. So I don't know if this would be the right time, Maimoon, to share our visuals, and perhaps everybody can talk through sort of the discovery process and how it pieced together.
Can you hear me?
Yes.
All right. Are you able to see my screen just to make sure?
Yes.
So yeah, it's kind of interesting coming at a sort of general project like this and trying to solve a technical issue, which is, okay, COVID-19 has occurred, the science fair is gone. How do we sort of try to, this is not a replacement for a science fair, of course, let's get that in mind, but how do we hype up a science fair? How do we make this interesting? How do we do something cool with new technologies? And something cool that students have, and they see, okay, these students have done it. What can we do with this technology? This is everything done here is completely free. Any student can download these applications on their computers, follow YouTube videos, and make better technology than our team has. And this really shows that when you come together with a wide range of students and everyone contributes, everyone here has their own special skills and special technical skills. And when we put everything together, what type of product do we get in the end? For example, I am very bad at 3D modeling. So none of this 3D modeling is me. This is the high school students who've done this. Some students are better at coding than me. So they've done the website, they did help me with the back-end code. And some of the code I've done as a university student. And because of that, we were able to get a project done. So the basic idea is like, okay, you cannot really read this board here, right? So you click a button, you click the table, and then a pop-up of the actual presentation shows up, so the actual board, so the different parts, and you can scroll between the different board sections and look at it. And though this isn't interactive and cool like going to an actual science fair and talking to the science fair presenter, it still is a proof of concept that a virtual science fair is possible, that with more technology, with more additions, we can really work with virtual technology and give students a truly socially distanced experience of the MSAF Science Fair. I got nothing else to say.
Anybody else want to share sort of any surprises or hiccups or unexpected benefits of collaborating on this?
I mean, at least from my end, um, I was also new to at least VR. I've worked with CAD before, but I've never actually taken the CAD, put it into a VR application. Um, so one thing I found out pretty quickly is that this is all done in a web browser. So this was made so that anyone, regardless of whatever technology you had at home, you didn't need to have like a high-end VR headset in order to participate in this project or view the project. So one thing I found out pretty quickly was you can be sometimes a little bit limited by a web browser. One hiccup that came through my way was that I was trying to put in complex models into our VR application, um, but the browser did not take that well because it took forever to load up. So one thing, at least on my end, was trying to kind of simplify the process or the project, but at the same time trying to keep it as close to the real science fair as possible. So I had to kind of find that perfect balance of, okay, what's too complicated for a web browser, but at the same time, what still looks good and what still looks like a real science fair. And in the end, I was able to find that like happy medium, I guess.
Great, thanks. Anyone else? Any unexpected ways your skills came to good use?
I think the biggest benefit that, I saw.
Yeah, so on my end,
Sorry, go ahead, Maimun.
no, sorry, my computer just lagged out completely there.
Yeah, so the biggest benefit that, at this point, like a couple months ago, we had just an idea. And now looking back, probably the biggest benefit for me is just the accessibility that we were able to assign to the science fair that we've created. Um, I mean, it's simple, like as a proof of concept alone, creating this science fair is really cool. And it shows, the wide range of potential and different applications there are for VR and AR, especially with web browsers. But even past that, I mean, this project wouldn't have any value if it weren't easy to use, if it weren't user friendly, and if students didn't really embrace it and treat it like a normal science fair. But I think the fact that we've, been able to do that and that it's simple, that students take away, that they present their traditional science fair projects and they can just transfer it over to our virtual science fair. I think that's the coolest thing for me.
Anyone else?
I think,
Yeah.
sorry, go on, go on.
Okay. I can speak about the web development end, which was also a component in our project. So web development is very important, especially in this project. It's what the viewer sees when they want to find out more about what the summer interns for VR did. We benefited a lot from having multiple peer reviewers. It was great to have multiple people reading over the information because it had to be concise, but it also had to be very clear, because you can lose a reader very quickly if they see a lot of information. They might have some barriers to technology. So I think we did a really great job of making the technology and the website accessible, and we really had the user in mind throughout this entire process.
To add on to my last question, perhaps also if there are ways that you envision taking what you learned or developed as part of this collaboration into your school year or into your subsequent science fair projects. That'd be interesting to know as well.
Personally, I knew a little bit of CAD, and basically that's computer aided design, but this project honestly gave me a whole new perspective on what can be done like inside your own home. And so definitely like a lot of things that we did, such as the web page or using the A-frame to create a VR experience, is something that I definitely learned a lot from and probably will use in the future in my science fair project.
From my end, like at least in the projects that I work with, um, nuclear science is not really something you can often bring to a science fair. It's pretty dangerous. So a lot of the times, I've used to have like pictures and like videos. But I think one way I can make my projects more interactive with these new skills that I've learned is maybe like having a VR model of a like of a reactor, which you could have a headset, and obviously once the actual science fair gets up and running again after this whole COVID thing blows over, you could have like a judge put on a VR headset and take a look at your project, like something that might have just been a picture on a slideshow, which isn't really that interesting, can now become a little bit more interactive. Like once you put on that headset, take a look at the reactor as if it was in front of you instead of like just looking at a picture on a slide.
Yeah, adding on to that, I think that showing this project to other people kind of opens their minds more to what VR can do in the future and how they can present their own projects in a like completely different world than what they normally imagine.
I think something interesting I have to contribute is that in Canada, where I'm currently in, our universities are closed for the entire year, and it's possible until 2022. So a few projects have been brought up to me about VR since a few of my professors and students know I did this stuff. One of them is a virtual tour of our campus. We have a very nice campus that's right next to like this environmental reserve. And so to give students an opportunity who might not be in Canada, they might be from uh, the United Emirates or China, who might want to see campus and can't do it. And another thing we want to do is tours of the McMaster facilities, like the steel processing plant. These places are important for specific faculties, and able to give those tours and outline technical aspects of, say, a rolling machine or a press is very important to mechanical engineers, material scientists, and could actually be incorporated within university education. And that's something that I'm currently discussing with a professor at McMaster.
Great. Well, any other final thoughts before we wrap up? Okay. Well, I just want to say that from the MSEF perspective, it was really exciting to push the limits of what science fair means. As anybody who's been to a science fair knows, it's a pretty traditional setup with boards and tables set up, and judges circulate and talk to students. And for us to be able to think about an environment where we're pushing that boundary, whether it's like Akash said, where a judge can actually visually experience a part of his presentation, or whether it's not having to be in a particular space to experience a science fair, that's a really interesting and exciting prospect. And it's been really fun to work with this group of students who've come at it with different skill sets, different interests, and certainly very different science fair projects to collaborate. So with that, I look forward to directing anybody who's watching this to our website, scifair.com, where we soon will host the link to the work that's been done. And if there are any questions, we can always be reached at info@scifair.com. Thank you so much for participating in our session today.